In today's video, we'll be going over design concepts. A prismatic beam design is a practical design example involving regularly shaped cross-sections with constant properties over length. In general, structural components are designed for several different conditions and limit states. The loading conditions include bending, shear, torsion, axial load, bearing, buckling, and thermal. The limit states include service, which basically includes allowable stresses such as bending and shear. There's also deflections and vibrations. Other limit states include strength, which is the beam's capacity at failure. There's also fatigue and durability. There are entire courses that are developed to design specific structural materials. The design process is somewhat material dependent. However, in general, it is done to conform with jurisdictional code requirements. For example, in Canada, we must conform to the National Building Code of Canada. There are also different design provisions and standards that can be referenced. For example, we can reference the Canadian Institute of Steel Construction when we do steel design. We can use what we have learned throughout the course to design simple beams in steel and wood. When considering the service limit state, we will focus on allowable stresses and deflections. For loading conditions, we'll consider bending and shear. Let's take a closer look at designing beams using steel sections. When we design beams using steel sections come manufactured in rolled shapes. The standard sections, sizes, shapes, and properties are available in Appendix C of your textbook. An example of that table can be seen here. In Canada, when we design steel, we use metric sizes and we reference the Canadian Institute of Steel Construction. In the USA, they use the US customary units, which is similar to the imperial system, but not the same, and they reference the American Institute of Steel Construction. Let's take a look at a nomenclature example. Here we have W18 by 46. W is the cross-section shape, and as we can see here, it is a W-section beam which has a wide flange cross-section, which can also be seen here. 18 is the nominal depth of the beam in either inches or millimeters, and 46 represents the mass per unit length. If we refer to the table here, and look for W18 by 46, we can see that the depth isn't exactly 18 inches, which is why we call it the nominal depth. When we compare the depth to other shapes with the same depth, so basically this whole section here, we can see that the depth varies, which is why it's called the nominal depth. When we look at designing beams using wood sections come in solid rectangular sections. They can be a solid rectangular section like this, or a built-up section, which is basically shapes connected together to form a composite section like this I-beam here. There are two different types of dimensions that are used for wood sections: nominal dimensions and actual dimensions. Nominal dimensions are used to describe the size of a wood board before it is planed. For example, when we go to stores, we see dimensions like 2x4 and 4x8. Actual dimensions represent the final size of the lumber after it is planed. For example, we can see here that before planing, we have a 2x4 board, but its actual dimensions are 1.5 inches by 3.5 inches. Remember, we must use actual dimensions for design calculations. To quickly summarize this video, we went over different loading conditions and limit states that a beam can undergo. We also looked at the different dimensioning for beams using steel sections and beams using wood sections. In the next video, we'll go over the general design process for beams.